Good morning, everyone. All right, who's ready for summer semester? I am. Foxicans. It's the attitude I like to see. All right. All right. 8 a.m. Let's do this. So, uh, so a lot of the intro I sent in my initial email. I'm not. I'm going to try not to repeat everything that I said in that. But there are two sections. I have to pull up the times because I got the times wrong last last summer. 8 to 10:30 is this one, which is a little different than what's in the hub for your schedule. There is a 10-minute break. Every time I put this up for a vote of whether to have the 10-minute break or cancel it and just end lecture 10 minutes earlier, vote always turns out cancel it and end lecture 10 minutes earlier. So I'm just going to do that by default. If most of you do object to that, I don't care. I'll change. We'll do it the other way. But I think this is usually what students prefer. So I'm just going to do this by default. So 8 to 10:30, and then there is another lecture 11 to 1:30, all Eastern Standard Time. So if you're registered for this one, but you don't want to wake up at 8 a.m., if you're assuming you're in Eastern Standard, you can go to the other one. That's fine. I don't care which one you watch, or if you watch the VOD, that's fine too. But let's just get into it. The big theme of the summer course is this moves fast. Oh, by the way, if I haven't streamed in a while, so if anything's off with the audio levels or anything needs to be adjusted, just let me know in chat, and we'll get that fixed. I think I haven't touched any settings since last summer, so I think everything should be okay. But just in case, don't hesitate to let me know. There's nothing more frustrating than having a lecture with bad audio and then nobody tells me till the end of lecture. Now I have a whole video that's just kind of garbage. Just let me know early so everybody can have a nice video. So the theme of the summer course is speed. This is only 6 weeks long. You cannot fall behind in the summer class. I'm going to say that early, often. I already said it was the first thing I said in the email I sent out. But if you fall behind by even a single lecture in the summer, it can mean failure in the course. Like you even during the regular semesters, falling behind by a week or two, you really can't. I shouldn't say can't, but it's very difficult to get caught back up. In the summer course, that happens in one day. One day, if you don't watch a Thursday lecture live and then don't catch up on the VOD and that, or sorry, a Tuesday, and then the Thursday lecture comes along 2 days later, that 2 days of inactivity, you're already behind, and now you're at risk of failing the course because you're a significant amount of time behind, significant amount of material. Every lecture is a full week of content in the regular semester, so it all right. Here I turned it up. If that's too loud, too quiet, still let me know. So even falling one lecture behind is almost a death sentence in the course. You're almost guaranteed to fail. Students can get caught back up, but especially in the summer. Last summer, unfortunately, a lot of students failed for that specific reason. They waited until the last minute to do assignments. If you wait till the last minute to do an assignment, you're falling 3-4 lectures behind, and at that point they just can't get caught back up, and then they're emailing me panicked at the end of the semester saying, what do I do, how do I get caught back up? And I'm like, well, you already ignored my warning on day one. Sorry, you gotta take the F and try again. I don't want to see anybody be in that situation. I wanted to see you all successful, especially in a summer course. If this is the only course you're taking, this is what you're doing for 6 weeks, I don't want to see you walk away with an F. Like, that sucks. It sucks for everybody. And the most important thing is just keeping up with the content, just keeping up with everything. If you don't want to watch the videos live, I ain't gonna force you to watch them live. A decision I had to make. I choose to do that. It's probably, maybe I even should. But anyway, I choose not to do that because some people are in wild time zones that neither of the lectures line up. Like they're sleeping during both lectures. So I don't want to force them to wake up in the middle of the night to watch lecture. That's the reason I do that. But at least when you wake up, if you're in that situation, watch the VOD right away. Make sure you're keeping up with things, or else you're in danger of failing. That's how students fail in the summer. Get too laxed, fall behind, and never get caught back up. Can't get caught back up. Is the audio fine here? And there's like, I think 10 seconds delay, so I'll keep an eye on chat. If in 10 seconds I see that you say it's not, I'll turn it up again. I'll crank this thing all the way up. Okay, so let's get through this. In 115, I'm going to go through the syllabus faster than I usually do because things go fast. We got to get to the content. But the focus of 116, where 115 is usually how do you code at all, 115 shifts focus a little bit into how do you write large programs and understanding how your programs work. So we're going to do a lot of memory diagrams, which we do in 115 now, so that's a little bit the same. But these three categories, these are the three major things that we're focusing on. How to test your code without having to submit to Autolab. We still have Autolab, you still submit, you can still have unlimited submissions. But how do you test your code to see that it's right before submitting and without relying on Autolab? Because Autolab's not going to be there your whole career. So unit testing is going to cover that. OP, how do we organize our software? Once we have large pieces of software, lots of code, lots of interacting pieces, how do we organize all that functionality? And data structure and algorithms, we're going to learn 3 more data structures. You know 2 data structures now, 1 sequential data structure, which was your list in Python, and 1 key value store, which was your dictionary in Python. We're going to add linked lists, trees, and graphs to that to see different ways of organizing and working with our data. Almost perfect, but could be a little louder. Okay, a little louder. All right, and the expectations, I already harped on this a few times. Here's my 3rd time, 1 in the email, 1 just now, and then again right now. Keep up with the material. This course demands a lot of your time. An estimate of 12 hours per lecture. Usually that's per week, but in the summer it's per lecture, just the way it is. Which means 24 hours per week at a minimum you should be investing in CSE116. This should be, I guess, not quite a full-time job, but this should be treated like a full-time job. And then if you get done earlier, before 40 hours, you have some extra free time. But you should be planning to spend at least 24 hours each week on CSE116. 5 of those hours are watching lecture. I guess my math's a little bit off. I didn't account for that extra half hour. There's 2.5 hour lectures. I was counting for 3 hour lectures here. But 5 hours, so 19 hours per week outside of watching lecture. 19 hours per week. You should be expecting to sit down, work on the programming tasks, mostly doing your programming assignments for 19 hours per week. If you're not willing to make that commitment, you should probably just drop the course right now. That's what it's going to take to pass this class. On average, or at a minimum, I have some explanation here. I don't want to go into as much as I usually do because we got to get to the content again. But that is an average and it's an estimation, all that stuff. If you don't know all of the CSE 115 concepts, if you squeak by with a C in 115 or even a B plus in 115, you didn't fully grasp all of that content and you don't know everything about 115 today, right now, you're looking at more than 19 hours per week outside of lecture because you have to catch up on everything you don't know from 115 so you can go on to 116. We rely on that content in 116, so this may be higher for you if you've already done AP computer science in high school and you've already done object-oriented programming. Maybe this will be a little lower for you, but expect to put in a lot of time. It's going to take time, and you can't fall behind. This is the math of why you can't fall behind. If you're doing 19 hours per week and you don't do anything this week because there's no deadlines coming up, there's no deadlines threatening you. Well, now next week you're looking at, oh, I set myself up for math already early in the morning. 38 hours next week. Like, you got to make up those hours at some point. This math does count this week, even though there's no deadlines threatening. So if this week you just watch lectures and you just don't do anything else, guess what you're doing the next 5 weeks is lots of fucking excuse my language, lots of work, lots of extra work. So keep up with it, put in the hours. Don't come complaining to me that you've been spending 20 hours a week on this course, because I'll very clearly point out that I expected 24 hours per week and that you're under my estimate anyway. Expect to put in the time. Every class says this. At 116, more than most other courses you've ever taken, this is actually going to be true. You can ask other students. Oh, speaking of, I didn't mention the links. You can ask other students, go over in the Discord and just go in the 116 channel and be like, hey, is Jesse full of crap with this 12 hours per lecture, 12 hours per week for the fall and spring? This stuff, like, does this course actually take a lot of time? And I would assume that you'd get a flood of comments saying, yes, oh my God, do not fall behind, you will fail. Piazza, if you click this link, it'll take you to the office hour schedule, which I don't think Gerlene's put her office hours on, but Rancy's and I have our office hours on there. And to ask questions, etc. Memory diagrams, those will be important moving forward. If you've had memory diagrams in 115, you know what this is all about already, but these links will become very important once we start talking about memory diagrams, which I guess is today because the content goes quick. Every time I show code in a lecture example, especially my slides, that code will be in this repo here. You can go through that repo and take a look at all the code examples for the semester. Autolab, where we're going to submit the assignments, and YouTube, you found this. If you're hearing me right now, you already found that link. Yeah, that's all I want to say about those. The Discord's less important because we have YouTube chat here, but I usually watch Discord during lectures. I'm not going to do that because we have YouTube chat. And the way you're assessed on the learning objectives of the course is through two methods. Those of you who are familiar with the fall and spring semesters, there are no interviews in the summer. Just logistically, I don't see a feasible way to make that happen. Unfortunately, I only have 2 TAs in the summer. I don't see a way of making it happen. I wish we could get them in there, but it's just not happening. I'm sure you're all heartbroken about it. It is kind of sad. The interviews do give you good practice with real-world job interviews, but unfortunately, it is what it is. So 2 methods of assessment. One is, can you read code? These are assessed through the memory diagram quizzes. These are traces, and if you can trace through code in memory, then you're good on the quizzes. And then writing, these are your programming assignments. So read and write code. Can you read and write code? That's what I want to know. We do that through quizzes and programming assignments. In OOP and data structures both. And writing, all of the programming assignments are going to involve testing as well. So this is where I'm assessing your testing ability. And how you're going to be graded. This is part of this is half of the picture of what it looks like. There are 2 quizzes. These are broken into a midterm and a final. So the word quiz might be a little skewed for the summer course, the way it's structured. But there are 2 quiz requirements, an OOP quiz and a data structures quiz. And you must pass both of them to pass the course. And also 8 programming tasks. You must complete all 8 programming tasks to pass the course. If you're not familiar with this and you're used to a percentage-based grading system, this is not that. What's up, Dev Partat? This is not that. This is not a percentage-based where you get like an 86 on a program assignment that's averaged into your grade. No, these are the learning objectives of the course, these 2 quizzes and 8 programming tests, and you must satisfy all the learning objectives of the course, and they're assessed through 2 quizzes, 8 programming tests. You have to complete all of these to pass the class. If you get both quizzes, you pass both quizzes, you're doing great on those. You complete 7 of the programming tasks, and you just can't complete that 8th programming task, that will be an F in the course. You have to complete all these things. These are the things that you need to know in order to move on to 220, 250, move on with your career. You need to know all this stuff. So you do have to pass all of these to pass the class. People who are taking this class for the first time, can some interview questions be posted so even though there are no interviews, people can still try to answer them to get practice? I can give you, I don't want to get too off track, but I can give you a few of them right now. Any topic that we cover, one of the interview questions is, explain this topic to me. Yeah, you need all of them. And the programming tests, I'm hesitant to even say this because some people will strongly disagree with me, but I don't think the programming tests are too difficult. And by that I mean that I could easily crank up the difficulty. They could be a lot more difficult. Oh, I got a typo right here. Oops. They could be a lot more difficult. I try to keep them to assessing the learning objective only and not just piling on a whole bunch of crap and a whole bunch of repetition asking you to do. If it's the inheritance programming task, I have an abstract class and then 2 classes that extend it. I don't have you make like, okay, now do 5 classes that extend it and 3 more abstract classes. There's not a whole bunch of volume and stuff. I try to get them to the point. Do you understand how to code inheritance? And then once you prove that, you move on. So they could be a lot more difficult. I don't know. I try to get it down to just, do you understand the concept? Do you understand how to write code that applies what we've learned in lecture? If you can, then you should be able to cruise through it fairly quickly. But if you are missing some key concept, that's where it's going to take you a lot more time. And you're learning the concept, so it's expected that you take a lot of time as you're learning these new concepts. So they are time-consuming, but they're not as difficult as they could be. Let me try. I kind of dug myself in a little bit of a hole here, but let me try to dig out. Is if this were a percentage-based graded course, the programming tests, I would 100% make them more difficult. They would be more involved. There would be more, just more volume there. They would be harder. So I can distinguish between finishing it with a 60% and finishing it with 100%. Since it's pass-fail, I don't put the bar too high. Okay, so I kind of jumped ahead to the program tests. I see the questions in chat. I got to explain the quiz structure for the summer. It's a little different if you did take it in the fall or spring. It's a little bit different, just logistically, that we got to do things a little bit different. So the one thing, if you're not familiar with the fall and spring, just ignore when I say that. But there are 2 quizzes in the fall and spring, or last semester especially, there were 6. We have time to split things into smaller quizzes. Here there are only 2. So we got OP and data structures, the 2 big learning objectives. There's no quiz on testing. 2 big learning objectives, 2 big categories of the course. You have to prove that you can trace code using either of these. These will be through a midterm and a final exam. So a week, I forget which week, but a little past that halfway mark, there's a midterm exam and then a final exam on the last lecture of the course. And the schedule's below. You can take a look at the schedule if you want to know right away when these things are. These need to be done in lecture. This is the only case where you have to be at your scheduled lecture time for the midterm and final exam. Obviously, still remote. The course is 100% remote. You never have to come to campus. Some of you are living halfway across the world. I don't expect you to come to UB, come to Buffalo. But you do have to be there at your scheduled time. So the midterm and final will be the same structure. It'll be the same exact thing. Both of them will be 2 traces for OOP and 2 traces for data structures. So both of them, same exact structure. Meaning, and I have my paragraph here. I don't like the way I wrote it. It confuses myself. So I'll try to explain it a little better in words right here. The midterm will have 2 OOP traces and 2 data structures traces. And by that I mean I'll give you 4 total programs to trace, and you'll generate the traces for all 4 of those. The traces will be done on the tracing tool, one of the links up at the top of the website. And for those 4 traces on the midterm, let me hold off on that one till the next section. The final exam will be the same exact structure: 2 OOP traces, 2 data structures traces. Same exact structure. This means that after the midterm, none of the lecture content will cover traces or won't be assessed on traces. I might still do some traces, but none of the content after the midterm will be assessed through a trace. You'll never have a trace on that content, meaning I think I cut it off before trees even. I don't remember. But graphs aren't on there. Polymorphism aren't on there. I know those two I definitely cut. So total between the midterm and final exam, you have 4 traces for OOP and 4 traces for data structures. So you have 4 chances to prove that you've completed the OOP learning objective and 4 chances to prove that you've completed the data structures learning objective of can you trace through code that uses OOP, can you trace through code that uses data structures. You need to complete one of those for each. So for OOP, 4 total chances, 2 on the midterm, 2 on the final. You need to complete one of those traces successfully, which are graded on a pass-fail basis. You can make some mistakes as long as they're small mistakes not related to the learning objective itself. And if you pass one of those 4, you've completed that learning objective. So out of the 8 total quizzes, the 8 total traces, if you complete 2 of those and they're 1 OOP and 1 data structures across the 2 exams, then you've completed the learning objectives for the quizzes. So the 2 quiz learning objectives, 1 out of the 4 OOP quizzes, 1 out of the 4 data structures quizzes. And I kind of mix the terminology. A trace or a quiz, I'm saying, is the same thing. So I see the midterm as 4 separate quizzes or 4 separate traces, the way I'm using the word quiz. And if on the midterm, say, for example, on the midterm, you pass all 4 traces, or on the midterm, you pass 1 OOP trace and fail the other one, pass 1 data structures trace and fail the other one, then in either of those cases, any of those cases, you're not taking the final exam. Final exam is optional. Final exam is effectively a last chance to be able to complete the quiz learning objectives that you did not complete on the midterm. So if you study, prepare for the midterm, crush it, you're not going to the final exam. You don't have to be there, and your semester can end earlier. Yeah, final is no application objectives. That's what I'm saving for the application objectives section. I'll explain. Midterm, you can earn application objectives. Final exam, you cannot. That's my incentive to get you to actually take the midterm seriously. We'll submit right in the tracing tool. I'll set up the tracing tool, so you do your trace on there, you click submit. I would recommend taking a screen capture also, just as a backup for yourself. But you can submit right on the tracing tool, and then we'll grade right on the tracing tool as well. Tracing tool's got quite a few new features added. Yeah, crush those traces. Some students do really poorly on the traces. I'm not 100% sure why, but study the traces, take them seriously. I suspect my guess for this is that the programming tasks you have to take seriously. Like, you just sit there for hours until it's done. But the quizzes, you prepare for it more like an exam, and it's easy to not take it as seriously, not study as well for these. I don't know, but that's just a guess. But anyway, take the quizzes seriously, take the midterm very seriously, and then you don't have to sweat the final. Okay, and then where your grade actually comes from, so that's just passing the class. Where your grade actually comes from is application objectives, and here's this nice chart. That's how you're getting your application objectives, that's how your application objectives map to your grade. If you get 0 application objectives, but you get all of your learning objectives, then you're still passing the class. So application objectives is strictly how you're improving your grade once you've passed the class. So this is how you're earning your A or whatever letter grade you're aiming for. And most of the application objectives are designed to incentivize you to stay on track with the content. There's actually, I think, 0. Yeah, 0 in the summer. Application objectives, that are asking you to go above and beyond the learning objectives. All of them are incentivizing you to stay on track. That's how important staying on track is. If you stay on track, you're going to get an A. Let me say it more succinctly than that, actually. You have to pass all the learning objectives to pass the class. You have to, or else it's going to be an F. You have to complete all the learning objectives and prove that you can do all this stuff to pass the class. My offer to you is, if you stay on track, which if you don't stay on track, you're probably going to fail anyway, because you're probably not going to complete all the learning objectives. And I don't want to see that. So my incentive to you is, hey, if you stay on track and do these things that you have to do anyway, if you do them in a timely manner, you can have an A. You did the same stuff as anyone who passed, but if you do that in a timely manner and stay on track, you can have an A by avoiding the risk of failure, the risk of falling behind and potentially failing. If you just squeak by and barely complete everything at the last second, you can still pass the class, but if you ignored all my advice of staying on track, staying on top of things, working your 24 hours per week, you're going to be lower on this chart. So logistically, there are 16 application objectives you can earn from the tasks and 8 on the quizzes. I'll do the quizzes first because it's easier to explain. Every trace that you complete on the midterm is 2 AOs. So there's 4 traces on the midterm, each one worth 2. That's a total of 8 application objectives you can get for the midterm. So you can get a significant grade boost by preparing for the midterm instead of relying on the final exam. It's one of the easy ways to fail this course is not taking the first opportunity for a quiz seriously, which is the midterm this summer. Not taking the midterm seriously and then saying, well, it's basically a free roll. I'll take the midterm. If I do good, fine. If I don't, whatever, the final exam's there for me. Take the midterm seriously. This is my offer, is 8 AOs. Big boost in your grade. You can go up to a C immediately, even if you don't get any of the programming tasks. And improve your grade by taking the midterm seriously. And if you do take it seriously and you are earning some AOs and then also not having to take the final, you get a lot of reward for that. So please take the midterm seriously. If you don't take the midterm seriously, or maybe you did take it seriously and things just didn't go your way, that happens too. You do still have the final exam, but the final exam will not offer any application objectives. Your final exam is your last chance to pass the class. You're not getting any incentive to finish anything on the final exam. That doesn't make sense to me. And then the deadlines. The deadlines for the programming tasks, there's 3 deadlines for each of the 8 programming tasks. The expected deadline, and this is designed to really get you aggressively to get you to stay on track. Deadline is 2 days after the material for that task was covered, and it's at 8 a.m., so it's technically a little after, or a little less than 48 full hours. This is very, very fast. This is a fast pace. The idea is that you watch lecture, preferably live, and then do the assignment right then and there. And then we do have office hours. I told the TAs to prioritize office hours that are in that 48-hour window right after lecture. So Tuesday, Wednesday, Thursdays, and Fridays, those are big office hour days. It's my intent. Mine are on Tuesdays and Thursdays after lecture. After the second lecture, I gave myself like a half-hour break. I think exactly a half-hour break. And then I go to office hours right after that. So take advantage of those office hours, get the homework done right away. And it's 48 hours, so anybody in a different time zone who's sleeping during live lectures can wake up, watch the lecture, work on the assignment right then and there, and get that done. So my what I'm incentivizing and what I'm recommending you to do is treat this like a 4-day work week. That's Tuesday through Friday. You should be doing 116 pretty much exclusively, and then take a 3-day weekend and go back at it Tuesday to Friday again and get your programming test done right away. If you meet the expected deadline, 2 application objectives every time you hit one of these expected deadlines. So that's my incentive. If you're staying up to date, if you're doing your stuff right when you're expected to, I'm going to improve your letter grade, assuming you do get all the learning objectives done. There's a late deadline, so if you don't get the expected deadline, which I mean, it does go quick. That expected deadline is going to come and go fast. There is another deadline, late deadline, that's 8 a.m. 5 days after the material was covered. So if this was a Thursday lecture where the material was covered, then the morning before the next lecture is the reason it's 5 days. The morning before the next lecture uh, uh, is uh, is the late deadline, and the expected deadline is 2 days because if it's a Tuesday lecture, then it's due before the Thursday lecture. If you go a lecture behind, you're still working on the previous task, and a lecture is passing you by. That's why this is timed so aggressively. You're going to start falling behind if you don't hit that. So 5 days, this is timed because the Thursday, get it done before the next lecture. For Tuesday, it ends up over the weekend. It's a little awkward, but it's fine. But anyway, complete by the late deadline. That's one application objective. And the final deadline is going to be 11 days, which might be too long of a time frame. 11 days. This will be due midnight. Please note the 8 a.m. Eastern time. 8 a.m., 8 a.m., and then midnight. So different times on the deadlines. The 8 a.m. is because it's when the next lecture starts, of course. But the final deadline, 11 days after the material was covered, which if you're relying on any final deadlines, 11 days after the material was covered, you have several lectures going by in that time frame. If you're relying on any final deadlines, you are at risk of failing. There's no other way to say that. I mean, I guess unless it's specifically only task 8, because no other lectures have gone by. I don't know. If you're relying on a final deadline, you're at risk of failing. If you're relying on even a late deadline, I'd say you're at risk of failing. So the final deadline, probably a little too much of a time frame, but I always worry about someone who struggles with the assignment. Something just doesn't click for whatever reason. But they are keeping up with the new material. I just want that student to still pass. If that's you, I want you to pass without having to feel like you got screwed over by an aggressive deadline. So 11 days, almost 2 full weeks. It's in the summer. That's basically an eternity. That's a good portion of the class. That's almost a third. Like 11 days from now will be a third of the. Is that true? A third of the way through the material. Yeah, maybe not quite. Close to. So this is a long time. A lot of lectures are passing by in that time. So this is your last chance to pass the class, to complete the task, to not fail, but no application objectives for the final deadline. So expected 2 AOs, late deadline 1 AO, final deadline 0 AOs. But you have to complete by the final deadline. When the final deadline for task 1 passes, that's the first wave of failures where some of you will just be done with the course. Probably none of you who are actually here live, but if you're watching this on a VOD, especially if you're watching it several days after it was recorded, that will probably apply to you. That you'll fail on the task 1 expected, or task 1 final. Okay, no textbook. All the links are provided. All the university stuff. If you need counseling, please go get any help that you need. And then academic, I assume if this does apply to you, feel free to reach out. I'm here for you. But I'll assume you that you know what that's all about. And if not, follow those links. And then academic integrity, don't cheat. This, unfortunately, I do have to spend a lot of time on this one. Any academic integrity violations will result in an F in the course. There's no A. Okay. We should have audio back. I'm complaining about the pop-up that says audio device, USB device not recognized, and it was definitely the mic. I don't know what happened there. Hopefully that's a one-off thing. I might have kicked the cord on that. Morning, Bonnie boy. There's no... Okay. If you do cheat, then it cuts out. If you cheat, it's going to be an F, was probably what I was saying. I don't care which of these things you've done, but there's no... What was I saying? There's no... Oh, there's no like 0 on the assignment or anything. It's an F in the course. Even when I do percentage-based grading, it is 1 violation is an F in the course. That's our department policy, and it's been my policy before it was department policy too. I definitely agree with it. It'll be an F in the course. So a few things that you can do is if you're brainstorming abstract solutions to code, and this isn't an excuse. I hear this in the AI meetings all the time as an excuse of, well, we were just talking about abstract solutions because I say that that's allowed. If you are actually talking about abstract solutions, this is perfectly fine, but you have to write the code independently. If you're both talking about abstract solutions, and I mean abstract as in you're not talking about what the code is going to look like, you're saying, oh, I think I'll iterate over the lines of that CSV file and convert everyone to a song object, and abstract solutions don't involve the code itself. If you say, I'm going to write a for loop, and then I'm going to create an array list, and then I'm going to split each line on commas, and then I'm going to take the value at index 0 and put it in a variable, and then that's explaining the code. You're not talking about abstract solutions at that point. You're explaining how to write the code, which means you're not writing the code independently. But abstract solutions are always okay. That's perfectly fine. If you think you do cross the line with AI, reach out to me before I reach out to you about AI, and I'll work with you. We'll talk about it. I'll never fail a student who's approaching me. We'll work something out that you're not going to fail the class based on AI. This is not in Scala anymore. I think, was it in Scala the last time I taught a summer? No, it was Java last summer too. Last time I streamed on YouTube. So abstract solutions are fine, but don't use that. I get that as an excuse all the time where I don't know exactly the mechanics of what happened, but I assume they explain the code line by line and then say, well, we didn't share code. And I'm like, yeah, you didn't physically like email them the code or share a repo or hand them a flash drive, but you explained every line of your code. That's sharing code. You didn't work on the code independently. So I want to make sure I draw that line because I'm sick of having to explain that in the AI meetings while a student is failing and crying in tears in front of me, and like, no, that's of course not allowed. If you're in doubt, it's if you couldn't write that code, if you can't recreate that code, if you and your friend can't both recreate that code and do that assignment independently with no trouble, then you cheat. You shared code. Okay. And this one, and I don't know how much this apply in the summer even, but this is the most common type of violation, so I want to make sure I highlight this one, is 2 students usually sitting next to each other. I guess in the summer it'd be like going on a Discord call or something, and working on the assignment together, where they don't always even think that they're cheating, but they'll be sitting right next to each other. They'll often be looking at each other's screens. I'll see students doing this in lecture sometimes, when we do have physical lectures. They'll be sitting next to each other right in front of my face, looking at each other's screens. They'll be pointing to each other's screens like, I know what they're doing. And sometimes I got to hit them with the AI and fail them. You can't just sit there and write code together. If you can't see each other's screens and you are just talking about abstract solutions, that can be fine. But if you're sitting next to each other and you can see each other's screens, you'd be surprised how similar your code ends up. And once I see 2 assignments that are similar enough that I don't believe that both students wrote it independently, I'm hitting both students with a violation. Like that's it's as simple as that. So if you sat next to each other and your code's looking extremely similar, I have the evidence that you crossed the line. It's going to be an F in the course. Using AI to write your code is becoming more prevalent. If you're going to ChatGPT and doing the assignments, you're risking an AI violation. The interview reports doesn't apply in the summer. In general, submitting any code that you didn't write, but also helping your teammate. Here's the other one I want to highlight because this is a little different from my policy in the past. I want to just give everyone a fair heads up. Allowing another student to access your work that you're submitting for course credit, if somebody else can access your code, that is a violation. And I've cared in the past. I'm not going to care anymore moving forward. I don't care how they got your code. If they have your code, you are in the wrong. And on the surface, in the worst case scenario, this would be one student literally just giving another student their code. Which I see that is definitely a failure. I don't care that you know all the learning objectives, that you can do all the assignments. I always have cheaters in these meetings say, well, I could do the assignment, I can explain all my code. Like, I don't care. You gave your code to your... I need a inappropriate word here. To your slacker... lack of integrity friend. Is that the most PC way I can say it? You gave your code to your friend and helped them cheat, which I see as a worse violation than actually cheating. It's the drug and drug dealer example. Who am I going to get more mad at? The junkie who needs their fix to be able to pass this course, or the dealer who's handing this stuff out and helping them be an addict? I'm going after the dealers. I think it's a worse violation for you to share your code with somebody else than to receive somebody else's code and submit it for credit. So I am 100% going after you if you helped somebody else cheat. And I don't care what your excuse is. You do have a responsibility to protect your code. On the more innocent side of things, I'll have stories of, oh, I left my laptop when I went to the bathroom and my roommate stole my code while I wasn't watching. You have a responsibility to protect your code. If you have your code in a public repo, for example, and somebody finds that repo out there on the internet, I've seen some students forking the homework repos and leaving them public, and then having their solution code out there for everybody to see. If that's you, you are in violation. You're allowing other people to access your code. You have to be more responsible. You have to protect your code. You have a responsibility to protect your code. And this one probably won't apply too much this semester, but asking the course staff to falsify your grade, this is another new one that I'm going to harp on moving forward in my career. Hopefully this won't apply for 116 summer. For 312, this is going to be a bigger deal. But anyway, asking me to falsify your grade, like, that's an AI violation. I'm sick of students doing this, where I'll get an email at the end of the semester, hey, I got enough AOs for a B, but can you just give me a B+? I'm giving you an F if you ask that anymore. This is very different than... did I not add it on here? This is very different than challenging your grading. Like, if you think we made a grading mistake, by all means, reach out, complain about it, argue about it, make your case, make your point and everything. If you think you should have passed, but you didn't, you think you have earned a passing grade or a better grade, that's fine. If you're flat out asking me to falsify your grade, you say, I understand that this is the grade that I earned, I just want a better grade. That's going to be an AI violation. Hopefully most of you are saying, what the hell? Students actually do that? Yes, they do, and it's ridiculous. And I'm so sick of it that I'm changing their grade to an F. Yeah, hopefully none of you would even consider doing that. I can't believe students do, but I'm going to start failing them. Yeah, I get this question so much. I should probably add this to the acceptable behavior in the AI policy. If you took the course before and you have code that you wrote, I do allow you to submit it again this semester. That's against the UB policy, and I assume that's why I get this question so much. But I do allow it in my courses. The reason for that is if you did rewrite the code, you're still the same developer, you're still the same person. Your code's gonna look very similar, and if I have your code from the past and your code from the present, and they just have your same style and everything, they're going to look similar. I don't really know how I'm gonna tell that you rewrote it. If it's going to be the same, it's going to be the same dev, same stylistic choices and everything. It'd be very hard to tell if you actually rewrote it or not. So I just let you allow it. Because if I disallow it, some students will still submit, and I just won't be able to detect that. I'm going to do slides in lecture. I do some live coding, but it's going to be mostly slides. Okay. Course introduction done. And when things are split up like this was Monday of week 1, Wednesday of week 1, Friday of week 1, but every week is a lecture in the summer. So on to lecture 2. Okay. I just downloaded it yesterday. Testing things out. Ocular is what I use. Which is, I do have that set as default. Is it actually going to open? Oh, cool. It does open in Ocular. Okay. So let's do this. Yeah, Paul is, we have opposite. So here's, oh, no, I can't even say that. Shit. But yeah, Paul and I have like polar opposite ways of presenting material. He's 100% live coding, and I'm mostly slides. Oh, I didn't even introduce myself, did I? I'm Jesse. That's it. I'll say a little more than that. So if you want to refer to me as Dr. Hartloff or Professor, that's fine. I do have a PhD, and I've been doing this for like 8 years. You can call me the more formal things if you want. I'll still respond. You're not wrong. But I do prefer just Jesse. We can keep it casual. There's no need to bring the titles involved and everything. Never liked the title doctor. It's not why I got a PhD. So just Jesse is fine. But yeah, Paul is live coding. Paul's the same way. He is a PhD. We're both doctors, but Paul and Jesse. He'll do the live coding, and I'll do the and I'll usually do the slides. It works well when we co-teach because then you have videos from both lectures. Yeah, I don't think Paul made any of his available outside of the semester that he teaches it. Would I recommend structuring notes during class? I never have a good answer for this. It's whatever works best for you. Personally, I didn't take notes. I found it best to give my full attention to the content as it's being covered and think through, like try to put the pieces together as I'm watching the lecture. That doesn't work for most people. So notes, whatever works best for you, typing or writing. Try out some different things, and whatever's working best for you, that's what you'd stick with. Okay, let's do this. Start with where every programming course, I gotta finish this tea because it's getting cold. Oh, cold tea. Oh. All right, so start with where any programming task should start. Hello world. So this is Hello World in Java. This course assumes that you haven't seen any Java code before, which is why we're starting with Hello World, but that you have seen code in some programming language. For most of you, that'll be Python if you're coming from 115. So I do assume you know the basics of programming, and these first 2 lectures, we really rip through the syntax of Java. So I assume that you understand what printing to the screen means, for example, and this is how we print to the screen in Java. So I'm just going to focus on Java syntax here. These first 2 lectures will also go very quick, aside from just the pace of the semester being very quick. These lectures, like each lecture has 50 minutes allocated to them. Those 50 minutes will also go very fast for that sounds weird the way I said it, but this like as the second lecture of a regular semester. So this slide deck is made to go in 50 minutes, and then we'll move on to the next slide deck in 50 minutes. And there's just a lot of content packed in those in each slide deck. So just be aware of that. The pace of each lecture is also going to go pretty dang quick. These first two lectures don't have any programming tasks associated with them, but I would recommend at least looking at programming task 1. You can do the code for it, but you can't necessarily do the testing yet, which it is a testing assignment. But I would at least start looking at that and get started on that before you fall too far behind. The testing, you can watch the lectures. That's what I was saying earlier. You can, like on this channel, you can go watch all my lectures from previous semesters too. So if you do want to get ahead, it's the same content. I'm teaching the same lectures as I just did in the spring, that I just did in the spring. So if you go to the videos and look at all the 116 lectures from the spring that was just covered, it's the same content, same slide decks. There was only 2 weeks in between. It's not like I had time to go through the whole course and update things. So it's going to be the same stuff. So if you do want to just get ahead on all the lectures, you could rip through the entire course right now. There's nothing stopping you from doing that. Or you can wait for the live lectures, which, especially for these first few before we can get to a homework assignment, can be a little tougher. But I would recommend jumping ahead to the unit testing, watching the unit testing lectures from last semester, so you can get started on homework 1, task 1, today, really, preferably. Okay, with that, let's get into it. So Hello World, this is the simplest Java example ever. It's just Hello World, and it's not that simple. Debatably, it can be a little bit simpler. I could get rid of the package declaration, but it can't get much simpler. So let's break this thing down and talk about it. We will see package declarations on every class this semester, so I want to make sure it's there right from the first example. The package declaration is pretty much synonymous with the directory structure. So every file is going to be saved in a specific directory, your source directory. For the examples repo, my source directory is called source, SRC for source. That's very common. That's where your source code is going to go. And then within that source directory, the directory where this file lives is going to be exactly the package name. So this is package week 1. It's found in the directory source /week 1. Then the class name, every file in Java is going to define a class with a little asterisk. We will talk about interfaces way later in the semester. I say way later, but in the summer it's like 4 weeks from now. Every file is going to define a class for now, and the class name is going to be the name of the file in our code. So every piece of code in Java is going to be within a class. So once we have a file where we want to write Java code, we have to have a class that we're defining. So we're defining a class named Hello World, and this class named Hello World is in a package week 1. So to find this code, if we're just looking at this and you want to find this in the examples repo, you would look in the source directory, the week 1 subdirectory, and a file named helloworld.java. That's where you're going to find this exact example in the examples repo on GitHub. And they will be labeled by weeks here. If you, in your mind, replace week with lecture, it'll be the same thing. It is... does the package declaration change the place where it's saved? The package declaration has to match the place that it's saved. So if you change one without the other, you're going to get an error, and your program won't even run. Java will yell at you, you'll get errors, and you'll get errors. So if I change this, if I go into this and just add like an S to the end of Hello World here, I'm going to get an error. Or sorry, you were asking about packages. So that same is true with the class name. The class name has to match the file name. The package has to match the directory, and Java will enforce these. If I change the package to week 2, I'm going to get an error because the file lives in week 1 and I said the package is week 2. And vice versa, if I change the package, if I move this file to a different directory without updating its package name, I'm also going to get an error. So this is actually enforced by the compiler in Java, that the package has to match the directory, the file name has to match the class name, is enforced. So that will always be the case with Java programs. There's no way around it, or else your code's broken. So it won't automatically change it, but you do have to change both if you change one. Okay, and then the main method. Oh boy, the main method. So the main method, for now, it has to look like this. We're not going to dive too deep into all of the keywords on the screen right now, but I will give a brief explanation of each of them. So public static void main, and then string array args. This is the main method. We have to have a method that looks exactly like this, and this is going to define the entry point to our program. When we run a Java program, what we're doing is running a main method. So if we have a class named Hello World and we want to run this code, we provide a main method that looks exactly like this. And then when we run this class, it's going to run the code within the code block of the main method, which just prints out hello Java right here. So there's a lot going on here. Static means that we can run this method, and just as a quick note, I'm going to say method. If whenever I say method, you hear function, that's perfectly fine with me. Basically the same thing. But whenever you put a function that's write a function that's part of a class, we call that a method because everything has to have a different name. There are subtle differences between the two, which we'll find out later this semester, next week. And in Java, all code has to be in a class. So Java doesn't have functions, it only has methods. So I'll say method all semester. You might, aside from this note right now, you might never hear me say the word function at all. It'll always be method in Java, but if I say method, you hear function, fine. For those of you who know, there is a way to pretend that you have functions. Some people call them lambda functions in Java, but it's syntactical sugar that is actually methods. Anyway, we don't have to talk about that right now. I'll say method all semester. So static means that we can call this method without doing extra work. We're going to find out later that that extra work is creating an object of the class type. We don't want to worry about that quite yet. Everything's going to be static for now, and the main method has to be static. Void means this method doesn't return anything. Main is the name of the method. String array is the type of the parameter that the main method takes. This is something that we're not going to use in 116, but it does have to be there, or else it's not a main method. And then public, which I'm not sure why. Oh yeah, that's why. And then public, which means you can call this code from anywhere. So the class is public and the main method is public, meaning from outside of this class, we can call the main method, so we can actually start the program. If this wasn't public, we wouldn't be able to access it from outside the class, and things wouldn't work. So once you have all these ingredients, public, static, void, main, string array, and args, for what it's worth, is a variable name. We usually are consistent and always call this args for arguments, which is actually the command line arguments. Again, we don't have to get down the rabbit hole too far. But this is a variable name. This is the only part of the main method signature that can change. If you want to call args something different just to be defiant for whatever reason, you could. But everything else has to be exact. Public, static, void, main, string array. Those pieces have to be there. If anything's off at all, for example, if you put capital M for main, it's no longer a main method. All of this has to be exact, or else it's not a main method. And Java's not going to know where to start your program, and your program just doesn't run. So this has to be exact. Character for character. It has to be exact here. And if you're wondering, you already know just like 10 minutes into Java why we don't use Java for 115 anymore. It's just too much. This is the very first, most basic example we can possibly have. And look at how many times I had to say, let's not go down that rabbit hole right now. Let's not get into that right now. There's just so much here. But if you're missing any of this, you don't have a Java program. Again, aside from the package declaration, we could use, if we put our files right in the source directory, we technically can use the default package where you don't need a package declaration. So one line we could get rid of, but everything else has to be here. As opposed to 115 in Python, print hello Python, done. But in 115, y'all can handle this. It's a lot of explanation, but we can handle it in 116 after you have a semester of programming under your belts. Or we're going to use IntelliJ throughout the semester. In IntelliJ, you create a class and you type main and then hit enter. It's going to autocomplete all this for you. So these days, we really don't have to remember public static void main. We don't have to memorize that because we have lots of tools that are going to help us along our way without having to, rely on rote memorization like we used to have to. We used to have to remember to type our semicolons and things like that. IDEs really help us out now. If a method is static, you can still call it through an object of the class. No. No, but it kind of acts like it does. Yes, you can use VS Code. If you want to use VS Code, that's fine. I'm going to show IntelliJ in lecture. We're going to support IntelliJ in office hours and Piazza. If you want to use VS Code, that's fine. But if you have an issue that's specific to VS Code, you're not going to get any help from myself or the TAs on it. So use it at your own risk. If you know what you're doing, presumably if you're using VS Code, you know what you're doing and we don't have to help you. But if that's not true and you want to use VS Code for some other reason, because somebody said it was cool, but you don't know how to use the tool, you're not getting any help. So you have to call static methods through the class. But if you are in a non-static method of an object and you just call the method, it'll implicitly go through the class. So it can kind of act like it is from time to time, depending on your exact situation. But if you have a variable that stores an object and you try to do variable dot static method, that's not going to compile. It's not going to work. Okay, and then finally we can write some code. So all of that is boilerplate. We need all of that just to run a Java program, and now we can finally write a Java program. And even printing to the screen is more complex than it has to be. System with a capital S, dot out with a lowercase o, dot println with a lowercase p and lowercase l. I don't know why. Well, some of those I know why, but I don't know why the lowercase l. And then give it a string, and it's going to print that to the screen. So this finally prints out hello Java to the screen. IntelliJ has a shortcut for this too, system.out.println, s out in IntelliJ, just like we did main. So you create your hello world, type main, enter, s out, enter, and the IDE is going to help us out. So we don't have to memorize all this stuff anymore. You'll probably end up memorizing this stuff by the end of the semester anyway, just by seeing it so often. But we don't have to anymore. We're not required to as programmers anymore to remember all that stuff. And then every have my phone right here, so I can keep an eye on the time. 9 o'clock. Okay. And then everything ends in a semicolon. Every statement ends in a semicolon. Don't forget your semicolons. But again, tools these days, IDEs, IntelliJ, it's gonna say, hey, you missed a semicolon right here, and point out exactly where you missed a semicolon. Long gone are the days where we have to chase down that missing semicolon. The IDE will just point it out for us. Okay, so that's our very first Java program. Hopefully that one wasn't too much. I mean, there's a lot there, but most of it you don't have to understand quite yet. So let's get on to some juicier stuff. Let's get into our first new 116 topic, which is a Java topic. So we're going to talk about variables and methods. And the big thing that we have to talk about here is typing. That's going to be the big thing. Because the methods themselves, the variables themselves, it's the same as Python for the most part. You have the name of the method, and then parameter lists, all the usual stuff that you've seen, variable declaration, variable reassignment, that kind of stuff. The new thing here is going to be typing. So Java is strongly typed. Your first brand new concept, the brand new thing that we're seeing. So this is what we want to focus on. Java is strongly typed. That means that every variable in your program must have a specific type, and variables of a certain type can only ever store values of that type. So I don't just declare a variable named num, where in Python you would just do num equals 2.4 and that'd be it. In Java, you have to declare your variable with a specific type. So double num equals 2.4 semicolon. This is creating a variable named num of type double, and this variable can only ever store doubles. It cannot store any other type as long as it's on the stack. As long as it remains in memory, it can't store any other type. So num of type double is going to create a variable of type double, and I can reassign it. I can say num equals some new double, that's fine, but I can't declare it, and I cannot store anything other than a double in this variable. So every variable must have its type explicitly declared. It is only during variable declaration, not during reassignment, so we wouldn't say double num again here. That'll be an error. It'll say duplicate variable declaration. You won't get any. You won't get to run your program at that point. So we declare variable num of type double and assign it an initial value here. Okay, so that's our first introduction to typing. So now methods, method declaration. Not too different than other languages, but a few things we have to point out. First, public static. For now, every single method we write is going to be public and static. All the three methods on screen right now are public static, and that's going to be the case until we learn about classes. Well, I guess we're learning about classes. We're using classes now. Until we learn about classes and objects, which will be next Thursday. And we will see a few non-static methods on Tuesday when we talk about unit testing. Unit testing works with non-static methods, so we'll start dabbling in it a little bit. But this week, for sure, everything's public static. Public means we can call the method from anywhere, as we talked about with the main method, which very few of our methods are not going to be public. We want to be able to call our code from wherever. And static meaning we don't have to create objects of this type to be able to call the method. So same thing as the main method. We're still using those two keywords for our methods here. So it says few weeks. So whenever you see weeks, you can read that as lectures for the summer. And then another new thing, double. So every method must specify its return type. So a method has to have a return type. This means that multiplied by 2, not only every variable needs to have a type, but multiplied by 2 has to have a return type saying what type of value is going to be returned. So multiply by 2, whenever it's called, this method call is going to resolve to a value of its return type. So I'm saying multiply by 2 must return a double. And this is a very strict contract you're writing with Java that you're signing in blood. You're saying this method multiplied by 2 will return a double. And if you don't satisfy that contract, Java is going to yell at you and it's not going to run your code. So multiply by 2, no matter what happens in this method definition, it absolutely must return a double. If it doesn't return a double, we violated the contract, we broke the contract, and Java's not going to fulfill its side of the contract, which is running our code. So we have to return a double. Okay, is double and float the same? Yeah, basically. They're both floating point values. I don't even know if this is true anymore, but it used to be at least. Floats were 32 bits and doubles were 64 bits. I feel like floats are usually 64-bit. I don't know. I might be making that up though. I might have just hallucinated that. But they're treated mostly the same. I always use doubles over floats because if floats aren't 64 bits in whatever language I'm programming in, I want the 64-bit version. Double's going to make sure that I get that. So we have to return a double. So every variable needs a type. Every method needs a return type. And parameters are variables. Variables need types. Parameters need types. So every parameter also needs a type. So multiplied by 2 takes one parameter named input of type double and will return a double. So that's our whole method signature, aside from the public static part that we talked about. Can the return methods type be different? Can the return methods type be different? I'm not exactly sure what you mean by that. If the return type is double, we have to return a double. The input can be a different type than the return type. Maybe that's what you're asking. So if I wanted this to take a string and return a double, that would be perfectly fine. But once I say it returns a double, I have to return a double. There's some wiggle room in there. If I returned an int here, for example, which is double is a number that can have a decimal portion. An int is a number that has to be a whole number. If I return an int, Java will implicitly convert that to a double for me. I'm still returning a double, even if it doesn't look like I'm returning a double. So there's a little like illusion in certain situations, but you do have to return a double. But if I returned an int here, I wouldn't get any errors because Java's got my back on that one. Okay. And then finally the code. So we have input, which we know is going to be a double. We have to return a double. So we're just multiplying by 2 here. It's nothing fancy. I'm going to declare another variable x of type double. Input, which is a double, multiplied by 2, which will be an int technically here. And then return x. So I'm returning x. X is of type double, meaning that I've satisfied my contract. I am returning a double here. So I've satisfied my contract. This is valid code. It's going to run. Everything's going to be fine. And we do need to use the return statement, the return keyword, to specify exactly what we're returning. And throughout any path of this method, we must always return a double. In the next example, that'll be more important when we have conditionals. But no matter how we make it through the method, we have to always end up returning a double. Okay, and indentation doesn't matter. Okay, and then we can call our method. So multiply by 2 takes a double and returns a double. So we need to make sure that all of our types match up. So multiply by 2 is going to take num, which is of type double. So we're satisfied on the argument side. The argument type matches the parameter type, so we're good there. And then multiply by 2 will resolve to a double. So now we're on the other side of that contract. We're relying on that contract being fulfilled. Multiply by 2 will always return a double. So we know that this will resolve to a double because Java is going to enforce the contract. And we're assigning that value to a variable of type double. So num equals some value that's a double. Our types match on the other side too. So all our types line up, which was easy in this case because they're all double. But all of our types matched up, so this code is fine. And then we're simply going to print out that number to the screen. And we can have methods that don't return anything. If we want a method that doesn't return anything, that we call for what we call our side effects, like this method y, because why would this method ever exist? You would never write a method like this. I mean, maybe. I'd really have to stretch to conceive of some reason you would write a method like this that just prints to the screen with no parameters. But when we call this method, it doesn't return anything. If we don't want to return anything, we say the return type is void. So we set the return type to void, meaning nothing, and then we don't have any return statements. We can use the return keyword in a void method. That's fine, but it's still not going to return any value. We can just do return semicolon if we want to shut off the method. But void means that method returns nothing. So we call this method y for its side effect of printing to the screen and not for any return value. And when we learn about objects void, we will see lots of void methods. For now, void isn't going to be super useful until we have objects. And the program ends. Once we hit the end of the main method, program's over. Okay. And Java strongly typed, but I only showed you one type. I just showed you doubles in the previous example. So let's sprinkle in some more types here. Let's talk about four, I can count. 4 types that we'll see throughout the semester: double, string, int, and boolean. These will be very important, and then we'll start adding more complex types again when we talk about classes. So double, this is the one that we saw. This is any number that can have a decimal portion. So if I want to have any non-whole number, or sometimes even when I want whole numbers, you can still use doubles there and be fine. Be weird, but if you want any decimal portion, doubles your go-to. Doubles can't be represented exactly in the computer. We'll talk about this on Tuesday. That will actually be extremely important on Tuesday's lecture when we start testing. String. This is just like your strings in Python. This is a sequence of characters. And note that this is a capital S. This is a little bit different than our other 3 here. That it's, without getting too lost in details here, string is a class type, not a primitive. Double, int, and boolean, and any type that starts with a lowercase letter is a primitive type, meaning that it's stored directly as values, and any class type is stored as references to objects on the heap. You don't have to worry about what that means right now, and the good news is, or depending on how you look at it, we're going to pretend that strings are primitive values for this course. They do behave just like primitive values because they're immutable. I don't want to go down that rabbit hole, but we're going to pretend that they are stored by value and not by reference. So we're going to treat them just like doubles, ints, booleans, and everything except your data structures that you've done in 115. So we're going to pretend that that's a lowercase s, effectively, for 116. And then when you get to 220, your 220 instructor can tell you how wrong I was for doing that and how frustrating it is that we taught the wrong thing. And that's fine. They can rant and rave about it and teach you the right way. But we're going to pretend that they are primitives. The reason for that is it makes our memory diagrams much simpler. If we do strings the actual way that they're represented in the machine, your memory diagrams that involve strings will be way, way more complex and for no educational benefit. Like, you wouldn't really learn much. You wouldn't learn any of the 116 learning objectives by doing that. You would learn the 220 learning objectives, which is why they can straighten you out in 220 when the difference actually matters. But they behave like primitives. We're going to treat them like primitives. Okay, and then int, this is any whole number. These are numbers that have to be whole numbers, so no decimal portion. They can be negative or positive, but they have to be whole numbers. And integer division, one of the things that will come up is, integers, what will come up with integers is integer division. Integers can't have any decimal portion, so what happens when you divide 2 integers? The integer 6 and the integer 4, and I divide them. The result can't be a floating point number. I didn't mean to introduce that terminology, but they're called floats and doubles. Floats because they can have floating point values, which means they have values after the decimal portion. Even though we only use doubles, a double is still a floating point value. But we can't have a double as a result here. We can't have any decimal portion because division of 2 ints will always be an int. So this is what's called integer division. It's effectively the floor of the quotient. So this 1.5 that we would get, take the floor of that, and num2 is actually going to store the value 1. And it is the floor. It's always rounded down. So even 99 over 100 is going to be 0. Even though it's 0.99, it's basically 1. The computer is going to round it down to 0. It's effectively deleting any decimal portion. It's not doing any rounding or anything. It's just completely removing the decimal portion and leaving the whole number value. So this will come up a few times throughout the semester and will come up continuously throughout your career. A lot of times you want to avoid integer division, so making sure that at least one of your either numerator or denominator is a double instead of an int is going to avoid your integer division. But if they're both ints, you will get integer division. And you're going to be wondering where your precision is. You're going to lose some of the decimal portion. You're going to get the wrong values. You're going to have bugs. So always something to keep a lookout for. In non-strongly typed languages, it might just convert this to a float and give you 1.5. Java, strongly typed, result's going to be an int. And then Boolean, I don't have anything to say about this one, really. It's Boolean, you know Booleans. For what it's worth, lowercase t, lowercase f, whereas in Python it was uppercase t, uppercase f. But they're Booleans. Boolean's a Boolean. True or false? Okay. And let's stare at this code for a second. This is tougher in the summer. This is tougher when streaming, but if anybody has questions, I want to at least take a breather, but I guess I have to wait 10 seconds for the stream to catch up. But if anyone has questions, we did strongly typed, some basic Java syntax, method declaration, variable declaration. Strong typing is the big new one, and then 4 different types. Void, return types, main methods. Any questions on any of this before we get into this memory diagram? What we're about to do here is go into the first memory diagram or trace. We have a bunch of different synonyms for this. If I say memory diagram, trace, or quiz, I mean the same thing in all those contexts. But we're going to go through our first memory diagram. We're going to trace through this code and see how it works, which if you took 115 with traces, then this will all be review. But if you haven't, I do want to cover it because not all of you have seen traces. You haven't taken 115 with traces, or you didn't take 115 at UB. For whatever reason, if you haven't seen traces, I'm going to start at the top as though you haven't seen traces before. With the code double num equal 6.4, no. With the code double num equals 6/4 yield 1.5, no, because as soon as the 6.6 divided by 4 is executed, the right-hand side of the equal sign is executed before the assignment. So when this right-hand side is executed, it would say 6, that's an int, division by an int, that's going to be integer division. It's going to resolve to 1. And then after this expression completely resolves down to its value, then it's going to say, okay, now what are we doing with this value? In Java, look over to the left-hand side of the equal sign and say, oh, we're storing it in a double named num. And then that value that double gets a converted 1. So it'll be 1.0 instead of 1 as an integer, but it will get 1.0. So you do have to have either numerator or denominator has to be a double in order to get the division to work out, if you want the floating point value. Okay, so for the memory diagrams, we will use the tracing tool. I haven't been able to get my timing right using the tracing tool during lectures. Like I have the slides where the memory diagram's all made and I click through it. I don't know how Paul does it. He'll do live coding and then do the live trace also. If somehow he gets everything fitting in a 50-minute lecture. I don't know how he does it, but I can't do it. So here's what it will look like in the tracing tool if you were tracing this code through the tracing tool, which is the link, one of the links at the top of the website, tracing.csc.buffalo.edu. And this is what it will end up looking like when you go through the tracing tool. So you create your main stack frame, create your variables, put them on there, create your other stack frames, print things to the screen, nothing on the heap, no global variables ever in Java. Everything starts with a main method, so everything starts with the main stack frame. We don't have any globals at all in Java ever. So everything goes in the main stack frame, and then other stack frames that are called. So that's the very brief one. I don't want to just throw the completed memory diagram at you. We're going to click through. But when I do click through these and give the explanation of the memory diagram, it will be a different format than what we see in the tracing tool. So just a heads up on that, that I have my slides in a different format. Which really does bring up, I gotta fit in somewhere at least one memory diagram that I go through the tracing tool, just so you're used to seeing the tool in some degree. Whenever we have time in lecture, I think that's what I should prioritize so we can get you through the quizzes. So every memory diagram, every trace, every Java program is always going to start with the main method, and I'm going to have my stack and heap created here. We're not going to use the heap until next Thursday, but I'm going to start putting it on. No, that's actually not true. We're going to use it this Thursday for our array lists and hash maps, but we won't see it today. And then your input output, all this will already be set up for you in the tracing tool, so I don't have to talk too much about the structure of the memory diagram, but the stack is the big one that we're using here. This is where all your variables and stack frames will go. And in this memory diagram, I won't explicitly label my main stack frame. We would normally do that with the tracing tool. When we did these on paper, we wouldn't label our main stack frame because there was no good logistical way to do that, because your variables would be scattered, in between other stack frames and stuff. That's not the case in the tracing tool. Since it's electronic, it just resizes things and moves things down like you can't do when you're doing it on paper. So I won't have an explicit main stack frame, but in the trace tool you would. That said, if that would be considered a minor error if you don't have your main stack frame and you put all your main stack frame variables in the globals like you did in 115. I'm never going to fail you for that. Like, you're not going to fail a quiz because of that. So you should do it in the main stack frame. That's the correct way to do it. But that's never going to be what I'm assessing on the OOP or the data structures quiz. So it's not going to be a fundamental mistake for those quizzes, so you'll never fail because of that. So for what it's worth, I'm showing you two different ways. If you do it either way, that's fine. You're not going to fail the quiz, but the correct way would be to have a main stack frame on your stack. So just to get that out of the way. But especially since a lot of my memory diagrams in the slides are still set up without a main stack frame being explicit, there's no way I'm going to fail you because of that if you did what I showed you. So, all right. So first thing, I can print to the screen. That's going to go in our input-output section. Anything that's printed to the screen is going to go in this section. So I can print, yay, go us. And then variable declaration. Whenever we have a variable that's declared, we have num. The name of the variable is num. We're going to put that in the name column on our stack. And then the value that it's assigned is going to go in the value section. So name and value of all of our variables on the stack. And notice that we do not put the types of our variables. So num is of type int, but that doesn't show up in our memory diagram at all. We don't care about the types in our memory diagrams. The types are going to determine if the code can compile and execute, but it's not going to change what happens in memory at all, what those types are. I say that, but like it will determine this integer division, so kind of. But we're not going to put our types in our variables, in our memory diagrams. Declare a few more variables. Num2 gets the value 2.4. String 1 gets the value a string, and this is where, if you're like me, this does bug me for what it's worth. This might start bugging you that we're going to treat strings as values, as primitives. So this is technically an object on the heap, and string 1 stores a reference to that object. That's rarely ever going to matter in 116. And they do behave like primitives, so we are going to just put them on the stack as a value, right? As a value in the variable. So again, if it bugs you, take solace in knowing that it bugs me too, but it's a sacrifice we're making to make things a bit more simple and not get too distracted by something that isn't really a 116 topic. String immutability, it's just not really a 116 topic. For what it's worth, it used to be. We used to, when we taught the course in Scala, we did strings the proper way, and it was a learning objective, and if you didn't understand it, you failed the course and all that. We trimmed that back a little bit because it really is more of a 220 topic. We don't have to get that down in the details of things in 116. And then don't forget your integer division. Num3 does get the value 1, even though it's 6 divided by 4, you'd expect it to get 1.5. Num3, it's 2 ints divided by each other, that's integer division. Num3 gets the value 1. And then Boolean, Boolean name bool, that gets the value true. Name value, bool true. And we're going to print to the screen, I am num3, and then the value of num3. Num3 has the value 1. Print that to the screen. And then we have our first stack frame. Aside from, now we should have a stack frame right here labeled main. But this is our first non-main stack frame. Multiplied by 2 gets num2. Num2's value, and I'm catching myself a little bit here. Whenever I'm looking for a value, I need the value of num2. Try to get in the habit of looking at your memory diagram to get the value of num2. Don't go looking through your code and trying to evaluate what num2 is. With this example, it's simple enough. I didn't reassign anything, so all these values are just what the values are. But if you get in the habit of looking at the stack, it makes things a bit easier when a value is updating multiple times. Look at the value in the stack, and that's going to tell you exactly what that value is. And that's exactly what the computer does when it runs your code, is it's using the stack as a lookup table for all the values of these variables. And when it sees num2, it needs to resolve this expression that's just a variable. It's going to look at the stack, num2, resolve it to 2.4, and that's what goes right here, 2.4. And then we call multiply by 2. We call the method and get into our multiply by 2 code. So with this stack frame, we always draw as a solid box. In the trace tool, you click new stack frame, and it's going to do a solid box for you. So something that we don't really have to remember. But the reason why it's solid, we have to remember, is that we can't access variables outside of the stack frame. When we call a method, what we're getting is a completely isolated environment, a separate piece of the stack where everything that runs inside this box has nothing to do with anything that runs outside of that box. So when we get inside the stack frame box, it's a whole different world. And only the variables inside this box are accessible during the method call for that stack frame. Can you put a string and integer together without converting the integer to string? Yes, you can. Luckily. So this is something that would cause an error in Python. Good question. This would cause an error in Python where you had to do str and then parentheses around the num3. In Java, the concatenation operator is overloaded to take any types, where in Python you can only concatenate 2 strings. You can concatenate any types because this method, this plus method, which is part of the string class, can take an int, a double, an object. It can take any of those values, and what it will do is convert this to a string underneath the hood. So Java is calling a method that takes a string and an int, and then converting the int to a string and then performing string concatenation. So it appears like I'm concatenating a string and an int, but it's Java taking care of us underneath the hood and making things a little bit simpler, which I wish Python would do the same thing. I don't know why it doesn't. I'm sure there's a good reason for it. But Java will do the conversion for us automatically through the concatenation operator. So in this stack frame, we're creating a completely isolated environment for the method call. And a few things, we kind of have a checklist of things that we do when we have a method call. Create the stack frame, label it with the name of the method that's being called, draw a return arrow for where the value is going to be returned. So whenever this stack frame finally resolves down to a value, it's going to be assigned to num2. So we draw a return arrow to num2. That's where the value is going to end up going. And then finally, put the parameters, which there's only one, but there can be many parameters, of course. Put the parameters on the stack. assigned to the values of the arguments. So this num2 resolved to 2.4. So we have double input equals 2.4. So input equals 2.4 inside the stack frame. And then with all of that set up, we finally get to execute the code inside the method, inside this code block. And we execute this code, but with only access to the variables inside the stack frame. We cannot access any of these variables that are outside the stack frame. So we do double x, put a variable x on the stack, equal to input times 2. So x equals 4.8. And any variable declared inside the method call is declared inside the stack frame. And then we're going to return x. So once we return x resolves to 4.8. We're going to return that to num2, cross out the old value, and write in the new one. We never erase values. We always cross them out and add the new one. That's because we want to preserve the history. Our stack trace should be all of the history of everything that happened during this program execution. So we never want to erase information in our traces inside the actual machine. 2.4 would be erased and replaced with 4.8. But we want to preserve history in our traces. And then we're going to return x. Once we return a value, that method call ends. That stack frame ends. We cross out the stack frame. What's happening in the computer is that stack frame is removed from memory entirely. It's deleted. Input and x do not exist anymore after that stack frame returns. In our memory diagrams, again, we want to preserve history, so we'll cross it out so we can still see the evidence of that stack frame as it happened. Now this stack frame is gone. Once the stack frame returns, execution returns back to the stack frame that called it. So we go back to the main method. All of these variables become active again. They are what we call in scope again. And then we resume the program inside the main stack frame that called it. I was just going to get to your question too. What is the label of the new stack supposed to be? The label is the name of the method that was called. So this should have a box around it with main over here for the main stack frame. So once a stack frame is crossed out, input and x no longer exist. These variables are completely gone. They're inaccessible. Nobody can access or do anything with these variables anymore. And we print out the new value of num2, the 4.8. And here's where it does help to look at the stack frame. Okay, I need to resolve num2. Num2 is 4.8. I can't make any mistakes unless I made a mistake earlier, then have the wrong value here. I'm just looking up what the value is. I can't really make a mistake on that part of it. 4.8, that's the value. If I'm looking through the code, I'm saying, okay, what's num2? Num2, I might be tempted to say 2.4. And if I'm not, I can see this reassignment. Oh, wait, num2 equals, and now I got to go through this code again. Multiply by 2 of num2 was 2.4, 2.4, 4.8, return 4.8. Oh, it's 4.8. But I already did all that work. And so did the computer. Computer's going to do the same thing. Num2, look it up in the stack. Look it up in your lookup table. 4.8, print 4.8. And then why I added a parameter here just so we can see another stack frame with a value inside of it. Why call the stack frame, or call the method that creates a stack frame, label it with the name of the method being called, and put our return arrow for where the value that's returned is going to be assigned. Well, this method returns void. It doesn't return anything. It's not assigned to anything, so we just don't have a return arrow. No return arrow. Int val, the parameter, is assigned the value of the argument. So val gets the value 2. We execute the code. I return nothing. Gets printed to the screen. And then that stack frame ends. The variable val is gone out of memory forever. And we return back to the main stack frame. We get to the end of the main stack frame. And then the program ends. In the tracing tool, we would cross out our main stack frame at this point, and the whole program is over. And now I have all of the history, everything that happened in memory throughout the execution of this program. Oh, I forgot about this. Forgot I'm covering up stuff. Oops. I'm going to have to hop over to the other side. Let me just make myself smaller, maybe. Let's go right here. You'll hang out in the the lower right corner this semester. I think that's where I'm gonna block the least content. But if I am blocking content, don't hesitate to yell at me to move myself. But I'll hang out down here. And in the tracing tool, again, this is what it would look like. So now I want to talk a little bit more about how it looks in the tracing tool compared to how it looked in the slides. Is we do have an explicit main stack frame with all those main stack frame variables. We can see num2 had 2.4. It's a little covered up here. 2.4 and replaced with 4.8. Don't change the value here. Make sure you click the cross out button. That's going to cross it out and give you a new space to put your value. The string should be in quotes, but I'm not that picky about that. Some professors are. It's good to get in the habit of having the quotes if they're supposed to be there. Quotes when it's a value stored in a variable. No quotes when it's printed to the screen. It's good to get in the habit of getting that right, but I'm not going to be too big on that. And then each stack frame that you add, create the stack frame, do the same things that we did in the slides, and then make sure you cross out your stack frames each time. And here's your return arrow going over to num2, the Y, new stack frame, and everything that's printed to the screen. So same information, a little bit different way of doing things. At 9:41, okay. We went 1 minute over, and we started that a little early too, so we better start ripping through this one so we can end on time. See, if I this is what drives me nuts. If I double click that, like it's saying that it's going to open with the right program, but it opens in my browser instead. But if I go here and double click it, which I didn't even open the one that I just downloaded, then it opens in the right program. Windows drives me nuts sometimes. Okay, we got to keep cooking because I'm already behind 1 minute, and we gotta get through this. The first two lectures is just such a fast pace. Things due within each lecture. Again, the semester in the summer is going to go at a blistering pace all semester. Within each lecture, they don't all go as fast as these first two lectures. These first two lectures is just nonstop, rapid fire explanations of just nothing too complex, but just a lot of volume, just a lot of little things. So let's keep going with more little things. And it's all review of 115 concepts for the most part. We learned about typing there, but it's review of 115 stuff, but with Java syntax. So so I have the assumption that I can go very fast, that all you're learning is syntax, which shouldn't be too hard for you to grasp pretty quickly. And then again, taking your 19 hours outside of lecture, practicing this stuff, practicing Java syntax, that's what you should be doing this week if you're not looking ahead and working on task 1 right away. Definitely practice all this stuff. If you don't, you got to do it at some point, and you're going to already week 2 be asking for a 40-plus hour week. Don't put yourself in that position. Okay, so conditionals. Let's do this. The syntax of conditionals, I really don't have much to say. But when we get to the memory diagram, I'll have a little bit more to talk about. So the syntax with conditionals, it's braces, parentheses around the conditional, braces around each code block. So indentation doesn't matter like it did in Python. So we use the braces to tell where a code block begins and ends. We did this with methods in the last example too, but just to make sure that's clear, because I don't think I mentioned it explicitly. Braces are define our code blocks, not indentation. So with this program, we want to check a score and then give a letter grade based on that score. If you're in the 90s, it's an A, 80s, it's a B, 70s, etc. And then this should be A, C, F for our print statements here. So let's make sure we get that code, and we're going right into the memory diagram. We're diving right into it. This is what it's going to look like when you're using the tool. So let's go through the trace and give my commentary on it all, and then then talk about exactly what's going on with this. Okay, so start with the main method. That's how we always start. Our first thing is going to be a method call. That's a stack frame that's going to return. So we're going to create a stack frame letter, pass it the value 98 as an argument, and we're going to return whatever this method returns, we're going to assign that to a variable named result. Whenever this is the case in our memory diagrams, we'll put the variable that we're going to return to first with no value. And the reason we do that is so we can have a return arrow pointing to something. We're giving the return arrow something to point to. So even though this variable isn't going to be declared yet until we have a return value here, we're going to put it in our stack frame and have the return arrow point to it. And then when we do finally return from the stack frame, that value is going to go right here in result. So we create a stack frame. The method name is letter, and the return arrow goes to result. We put the parameter on the inside the stack frame, assigned the value of the argument, and then run through the code. We're going to create a variable named tens and assign it score over 10. Score is an int. 10 is an int. 10 is an int. It's called an int literal, meaning it's just a literal value that's not stored in a variable. And it's an int because I didn't give it a decimal portion. If I want this to be a double, I could do 10.0, and then it's going to be a double. But since I didn't put any decimal place here, any decimal point, this is going to be treated as an int. So I have an int divided by an int. I'm going to get integer division. And here's an example where I actually want integer division. I want just the tens place of the score. So I'm going to divide whatever score is by 10, and tens ends up getting just that tens place. This is one of the first things you'll do on the homework is, what is it? Sum of digits. Sum of digits is, I think, the second of 3 methods that you'll test and write for task 1. And sum of digits, the intent of that one is to combine integer division with the modulo operator to go through the digits of a number and sum up the values of all of the digits. So this example is meant to give you, to show you how to do this. And I like pointing these out. I used to not point them out, and then everyone said, you never show us how to do the homework. A lot of the lecture examples are directly showing you how to solve some of the lecture or some of the homework problems. And this is one of the tools that we're giving you to do that sum of digits. This is how you can effectively ignore the ones digit. We're using it to get the tens here, but if I had like a 4-digit number and I divide it by 10, it's going to be integer division, and it effectively shifts all of the digits to the right by 1 and erases the ones digit. So the old ones digit's gone and everything's shifted over by 1. And if I use the modulo operator, we'll see, I think in the next example, I forget when that comes up, maybe not until testing lecture. If you use the modulo operator and do %10, that's modulo 10, that's going to give you exactly the ones digit. So if you combine both of those in a loop, these examples are showing you how to, use those tools to get that sum of digits. That's the intended solution for sum of digits, not to just give it away, but I basically gave it away. Otherwise, that one's a little tricky if you don't know the strategy, don't know a strategy coming in. Okay, so and I've seen people do really weird things on those. I'm like, I should probably be more clear that I'm showing you how to do that in the lecture examples. I'm arming you with the right tools to succeed there. So tens, this is integer division. We get just the tens place. And then if tens greater than or equal to 9, that's true. So this code block is executed, and we return A. As soon as we hit a return statement, the method ends, no other code gets executed. So a few things here, no other code is executed. This is just the end period. Now, in this case, it would have been the end anyway. This is else if, and else. So all of these conditionals are part of one big conditional block, and there's no code after that block. So this was going to be the last line anyway. But since it was a return statement, it's going to return. And also, every path through this method, I kind of alluded to this earlier, every single path through this method return string, return type string, every single path through the method must return a string. So every way that I can get to the end of this method has to end in returning a string. So either this is true and we return a string, or this is false and this is true and returns a string. This is false, false, true, and returns a string. False, 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 or true, returns a string, and false, 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 and then else returns a string. So since every path through this method returns a string, then we've satisfied this contract. But if any of those paths don't return a string, then Java's going to say, hey, I expect you to return a string, and you didn't. You let me down. I'm not going to run your code. And this includes if I didn't have an else. So if I erase this else block, now if it's false, 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 I finish the conditional and run the code outside of the conditional, and there's no return statement there. So that would also be an error. I see that quite a bit in programming assignments. Students won't have an else in a situation like this, and then if they're all false, they won't return anything, which will happen. Java will be mad at that, even if all of your conditionals cover every single base that could possibly happen. So if I say if 10's greater than equal to 9, else if 10's less than 9, and then no else, and nothing returned after that, even though I've covered every possible situation, every possible value of 10's, Java's not going to care. It's going to say there's technically a path through your program that doesn't result in returning a string. That's an error. That's a expected string got void. It's going to be the error that you see, and it's not going to run. It's not going to work. Okay, so with that out of the way, we return A. Result gets the value A. Stack frame returns. It's out of memory. Score and tens no longer exist in memory. And we are going to print A to the screen. Print result, results A. And then get a new stack frame, letter, and the labels of the stack frames are just the name of the method. So even though we have letter is going to be called 3 times here, 3 times in this example, all 3 stack frames are just going to be labeled letter. We're not going to add any extra annotation to those. So it can, somewhat get ambiguous. When we're grading, we're definitely going to know what's happening because we gave you the code. We know what to expect and everything. But there could potentially be a little ambiguity there. But we're not going to label anything else other than the name of the method. So score 75, tens is going to be 7 this time. If tens is greater than or equal to 9, false. Greater than or equal to 8, false. Greater than or equal to 7, true. And for this one, we have a little bit extra inside the code block. I get this question each time. I'm going to say before anybody asks it here, is why am I doing this right here instead of just returning C? And the only reason is so I have something else to talk about in the memory diagram. I want to talk about variables being declared inside a code block. So I set this up specifically just so I could talk about that. When a variable, normally I would just do return C. That'd be the cleaner way to do this. So with a variable that's declared inside a code block, we have a different type of box, a dashed box. This is semi-permeable is the way I like to think of it, is whenever we're inside a code block, we do enter a little bit of a different environment, but we can cross this line. So when I'm inside the code block, inside the code block, I can still access score and tens. I can still access these values, these variables, because I'm allowed to cross this boundary. And I can also access anything that's inside the boundary. The big difference, which won't come up in this example, but it'll come up in the next one with loops, is when the code block ends, any variables declared inside the code block are gone and we cross out the code block. So after this code block ends, the variable result is no longer in memory. Score and tens will still be in memory, but result will no longer be in memory. So that's the big thing with code blocks, which apparently doesn't come up in Python. I assumed you saw that in 1.15 up until recently. So result equals C, and then return result. We're going to end the stack frame and the code block at the same time, but they are both crossed out separately. They just happen to be destroyed at the same time in this example. Again, the next example, it'll be a little more nuanced, and we'll see the differences there. Print out C to the screen. Result, get C, cross out A, write C. Call the same thing with 30. Nothing real new here. False, 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 else. Return F. Result gets F. Result gets F. Print F to the screen. And in that last example, when there's a code block, technically we could always have these dash boxes, but whenever there's a code block where no variables are declared inside the code block, you don't have to write your code blocks in your memory diagrams. If it wouldn't make any difference to the execution of the program, why bother? We're not going to bother. But if there's a variable declared in the code block, then we're definitely going to draw our dash box. So you could have an empty dash box here and an empty dash box here. That'd be perfectly fine if you want to do that, but it's optional. You don't have to. Why do it if we don't have to? Result gets F. F printed to the screen. So again, in the trace tool, main stack frame, result, cross out A, cross out C, and F. Your 3 calls to letter, your code block that only has result in it, and then no code blocks for the other 2 code blocks because no variables were declared, and print out ACF to the screen. Okay, loops. We keep going. All right, so the while loop, which is infamously missing. Is it still missing? Did they cover it in 1.15? I don't know. But anyway, the while loop, yeah, if you have or haven't seen it, I'm going to cover it anyway. The while loop is very similar to a conditional in syntax. It's while and then a conditional and then a code block, except this code block is going to execute while this condition is false. So as long as this condition, or well, it's true. As long as this condition is true, the code block will keep executing. So where a conditional, you'd say, if this is true, execute this code. A while loop is saying, if this is true, execute this code, then check the conditional again. And if it's still true, execute the code again and again and again and again until this is false. So if val is 10, 10 greater than 1 is true, execute the code block. That's going to divide val by 2. So 5 greater than 1, execute the code block because it's true. Divide by 2, that's going to be 2. So 2, or sorry, I did this as a double. 2.5 is, this is true. 2.5 greater than 1, true. Execute again. 1.25 greater than 1, execute again. 0.625, is my math right there. It's going to be false. So then we stop executing and we are done with the loop. So we're executing while the condition is true. Keep in mind with while loops and with for loops actually that sometimes the loop doesn't execute at all. So don't put like initialization code inside the loop because it might never execute. If val is -5, for example, well, this condition, -5 greater than 1 is true, well, that's false right away. This is never executed, not even once. So something to keep in mind with your loops that sometimes they're never executed. if the condition is false when you first get there. And I'm starting to use some... Oh, did I not? Do I not have that in my slides here? And I'm starting to use some different syntax here. I'll start sprinkling these in. I think they actually did start using these in 115 as well, so I don't think I have to talk about them too much. But this divided by equals, this is the same as saying val equals val divided by 2. It's a little bit of shorthand. When you get to 116 especially, I think it's time to start sprinkling in the shorthand and start showing you the different tips and tricks. Throughout the semester, I'll have more like tips and tricks like that. That I would normally hold back on 115 when you're first learning just the basics. I don't want to throw too much out there, but 116, you're ready for it. Let's learn some cooler things. Same with this. I think they've started doing this in 115 as well, so it's a moot point here. But x plus plus, this is going to be, or no, they can't because they don't have plus plus in Python. X plus plus is going to be x equals x plus 1. So we're incrementing x by 1. That's what the plus plus means. So for loop syntax, if a variable is declared inside, so code block is anytime you have a pair of braces like this. So we're going to see code blocks with our for loops and while loops as well in this example, as well as our if-else statements, as well as our conditionals. So whenever you have a variable that's declared inside these braces, you're going to have a dashed box, and that variable goes inside the dashed box. And the reason for that is that variable will be destroyed at the end of that code block. So we need some way to annotate that in our memory diagram, that we have a variable that lives just during the lifetime of that code block. So if no variable is declared in the code block doesn't really have any effect on memory. So we don't bother writing it. And one caveat to that we're about to see is this x it's outside of the braces, but it is still declared as part of the block for the for loop. So this x is going to go inside the code block for the for loop in our memory diagrams. That'll be the big thing we have to watch out for here. So for loop consists of 3 statements. One, our initialization statement, our conditional, and then our incrementing statement. The initialization statement is executed one time and one time only when we first arrive at the loop. The conditional is the same as the while loop conditional. As long as this condition is true, we're going to keep looping through the code block. And then the incrementing statement is executed each time we get to the end of the loop. So each time the loop executes, we execute this code again. Right, you can initialize a variable in a for loop, but not in a while loop. A while loop is only the conditional. So while loop is only this part. For loop gives us more power, lets us initialize and increment in addition to the conditional. And in general, it looks like this. Run the initialization, check the expression. If it's true, execute the block. Each time you hit the end of the block, call this, and then check the expression again. Do that until the expression is false, and then you skip to the end of the loop and continue your code. Let's see it in a memory diagram. Here's what the final memory diagram is going to look like if we use the tracing tool. And one reason why I put these here is you can practice, take this code, go to the tracing tool, in practice mode, do your trace, and see if it came out exactly like this. If it came out just like this, you're looking good. So I would probably not study this too much and use it more for practice and see if you can create exactly this. And then study it after you do the practice. Okay, so let's trace through this code. I took both our loop examples that we just saw, jammed them in one memory diagram, and let's trace through this thing. So the main stack frame, we would have a main stack frame labeled here. I'm having the old style memory diagrams, so I don't really have it here. Hey, Pop, we have a dog visit. So we declare val inside the main stack frame with a value 10. and then val greater than 1. So I declared val outside of the code block, and then I have my code block for the well. So val is in the main stack frame and outside of the code block. There's no variable that's declared inside this code block, and we don't have any initialization for a while loop, so there's nothing in this code block, so we're not going to bother doing the code block in our memory diagram for this while loop. But we are going to execute the while loop. 10.0 is greater than 1, so that's true. We're going to execute the code block. We're going to print out val to the screen, and then we're going to do val divide. Oh, here's my slide where I have it. Val divided by 2. Val equals val divided by 2. So val is going to get 5.0. Now val is a double. 2 is an int, but since val is a double, so at least one out of the two operands is a double. That means we're not going to get integer division. So at least one's a double, so we're getting floating point math here. So we do get 5.0, not 5, no truncation, nothing. And then we're going to check the conditional again. 5.0 is greater than 1. And Java does some conversions here. 5.0 is a double, 1 is an int. But Java is usually pretty good about mixing doubles and ints, as long as you're not assigning the value to an int. Like if I have a double plus an int and assign the result to an int, I'm going to get in trouble because I can lose precision. But if you're assigning it to a double, usually going to be all right. All right, so val 5.0 is greater than 1. We're good there. Execute the loop again. Print out 5, then divide 5 by 2. So val is 2.5. Check the conditional again. 2.5 greater than 1 is true. And I'm going to go through this pretty quick. You've seen loops before. No matter how you got to 116, you've seen loops. So I can go through this fairly quick. But 2.5 greater than 1, true. Print 2.5, divide by 2. We got 1.25, which is greater than 1. That's true. So execute, print 1.25, divide by 2. We get 0.0625. And this is the part that I just want to focus on. So we're looking at the minute details here of how this executes. That 0.625 is not greater than 1, but val still does get that value. So val gets the value. This is false, so the loop does not execute again. Even though val gets the value 0.625, it's never printed to the screen because the loop never executes while val has this value. So paying attention to the little details like that by going through line by line exactly how the code executes is important. Understanding that it will get this value that's never printed to the screen is something you just got to pay attention to, those kinds of things. And this is the first of probably many times that I'll say this, but when you're going through your memory diagrams, it actually can help to turn off your brain a little bit. And it always sounds weird when I give this advice, but turn your brain off a little bit. I see too many students doing poorly on the memory diagrams because they're overthinking things or they're making predictions. Like we like to do as human beings, we make predictions and kind of assume what the code is going to do. But this code is executed by a computer with zero intelligence, zero IQ. It's just blatantly following step by step. And that's effectively what you're doing when you're going through the traces. You are the computer executing this code step by step. So if you blindly execute it step by step, it can actually make things easier. Val equals 10, is this true? If it's true, execute this. If it's true, execute this. It's true, execute this. It's false, go over here. And don't overthink it. I just see that way too much with memory diagrams. Probably the biggest reason students fail the memory diagrams is they're trying to read the code as a human, trying to read a story here or something like that. Just go through line by line, slowly, methodically, and go through all the code one step at a time. So if you go through the code one step at a time, you'll see, okay, val does get the value 0.625, and then this is false, and then the block isn't executed again. and you won't make any mistakes like that. So it does look weird. This value is in memory, but never printed to the screen. And since val was not declared inside the while loop, it's still in memory. That's still accessible. We can still print the value val. We can, use it however we want. The for loop, not so much. For loop, the initialization statement is executed as part of the for loop code block. So here we do need our code block, and X is declared as part of that block. So X is inside this code block. The big thing where that's going to matter is when we get to the end of this loop, the code block is removed from memory, which means we no longer have access to X after the code block executes. Now, I'll talk about that again. I'll revisit that when we get to the end of this loop. So X equals 0, and then we run the initialization code once, and then X less than 5, that's true. So we're going to print X to the screen. Print X, increment X by 1. So cross out the old value, new value is 1. Check the condition again. 1 is less than 5, that's true. So we execute again. Execute again. I'm skipping the details here because, it's one of the most basic loops you can see. You've seen this in 115 or however you got here. You've seen this before. And then X, the one I want to focus on, just like the last one, X will be incremented to 5, and then 5 less than 5 is false, so the loop doesn't execute again, but X does get the value 5. X is assigned the value 5, and then 5 is never printed to the screen. But it does get that value that's never printed. So just like val getting 625 that's never printed, X gets 5, but 5 is never printed. Because the condition is false, but X had to get to a value that made the condition false, but the loop is never executed with that value that made the condition false. So a little nuanced thing, but definitely important. And then we cross out the block. Once we get to the end of the block, we cross out that code block, and any variables that were declared as part of that code block are no longer in memory. So X is no longer in memory if after this code block, after this loop, we tried to say system.out.println X, we're going to get a variable not found error. It's going to say, you're telling me to print out X, but I don't have any X in memory, because we cross out code blocks and stack frames, but the computer actually removes them completely from memory. It has no recollection of X ever existing. Even though it just went through this loop, it has no recollection of X ever existing. So after the code block, it will not know what X is. It will not know what you mean by X at all. And this is usually a 115 thing. You'll pull out your hair in 115 and say, X, it's right there. How can you possibly not find it? And you start swearing at the computer and banging your keyboard and get frustrated. But it's because it's declared as part of the code block. Code block's gone. Can't access it anymore. So this is all in the main stack frame. This would all be in the main stack frame. So X doesn't exist. And this is something you might do in 115. It's something you learn pretty early in your programming career. That you're trying to say return X or return a variable that was declared inside a conditional, and you're trying to return it outside the conditional, and it just won't return. It won't find the variable, and you get frustrated and trying to figure out what's happening. But you learn that lesson pretty quick that even if you don't know exactly why at the time, actually we do memory diagrams in 115 now. Should I guess. But this is the reason. The code block ends, destroys the variables, and then you can't return it after. At least in Java. I think Python's a little different, which makes it even more confusing because 115 and 116 is different. But this is how it works in pretty much any language. Except Python? I don't know. I gotta play around with Python and make sure I know exactly how that works. Alright. Java works like this for sure. And then in the tracing tool, this is what it would look like. And I think we do have, we have 15 minutes. I'm going to hop over to the tracing tool and trace probably this one. Trace this one out. So the meaning of x plus plus is x plus equals 1. Yes. which is x equals x plus 1. Trace doesn't let you cross out part of the block, just the whole thing. Let's hop over to the tracing tool. Can I cut and paste from this? Copy text. Okay, so that's all the plan stuff. Let's go off the rails a little bit here. Oh. So, right. I gotta grab my phone. Okay. Let's see if that did actually copy this code. Of course it didn't. Alright, off to IntelliJ. Loops. Where are we? Okay, to make this a little bigger. All right, so let's do a live trace. Can you start from step 1 on the trace tool? I've never seen one before. Yep, that's what I want to do right now, because I since I'm showing a different format in the slides, I want to make sure I get tracing tool in whenever we can. And lecture 1, we happen to have enough time to get a tracing tool example in, so let's do exactly that. Heap we won't need for this one. So I'm going to make that as small as I can. And they changed this again, didn't they? Pop out code to make it draggable. Oh, come on. You're killing me. I want it draggable. I don't want it. Oh. But it deleted my code. Zaid, fix it. And it's gone. Alright, well, I'm not messing with it. We're just going to live with it. Okay. So let's trace this. So I'm going to create a stack frame. I'm going to label it main. And then first thing I get is val 10. Oh, I got heap. So val gets the value 10.0. And then val greater than 1. And I'm kind of looking ahead and seeing no variables are declared in this block. So I'm not going to worry about creating a new code block, but we will in the next one. So val equals 10, val greater than 1, that's true. Val print to the screen, create new IO line 10.0. So print to the screen, and then we're not going to edit this. So this mistake some students make, not too often, not too common a mistake. We're not going to edit the variable name. We're going to cross out the value and put in a new value for the variable, because we want that history of how the variable has changed over time. And then 5 greater than 1, true. Should change this example so it doesn't execute so many times. 2.5 greater than 1, true. 2.5 and then up val divided by 2, 1.25, true, 1.25, divide by 2, 0.625. That's false, so it's never printed to the screen, and we move on to the next one. Stack frame is every method call creates a stack frame, and when that method call ends, that stack frame is destroyed. All right, so now we get to the for loop. Let's see, can I? Right there is about good. So now we get to the for loop, and for this, I have X being declared inside a code block. So I'm going to click this menu and create a code block in this stack frame. So I have a code block, I have my dashed box, and I'm going to create my variable X inside that block. X equals 0. 0 less than 5 is true, so print 0. 0, increment X to 1, print 1, increment this to 2, print 2, increments to 3, print 3, increment to 4, print 4, increment to 5, and now when it's 5, 5 less than 5 is false, so we do not print 5 here. And here's where the tracing tool comes into play, where we get something a little bit different, is we do cross out this code block. So now 5 is no longer in memory, but val is, but we're also at the end of the program, so we're going to cross out the entire stack frame as well. Cross out the whole stack frame. And there's our final memory diagram for this code. We've created a code block, crossed everything out, updated things, printed things to the screen, and got our whole thing. And we have 9 minutes. I can do the other one too. So if there are any questions, I'll keep this open. In case, and I'll watch for questions, and I can come back to that. But I do want to do probably plus minus, so we can get some stack frames in here too. Though this is really going to be is there a way that I can finagle this? Okay. Okay. Wait, we got this. Hey, all right. We hacked it. We hacked it to our betterment. Okay. So for this, we want to create our main stack frame. Create stack frame. Main is going to get a variable result that's going to get the result of a new stack frame. So we click new stack frame. This is called letter. Letter has score, which is going to be 98. And we want to add our return arrow. Mark as returning to this variable. So when this method returns, it's going to go right here. That's where the value is going to go. Yeah, the increment and executes at the end of each block. So each time we hit the closing brace for an iteration of that loop, then we execute this code here and then check the condition again. So it happens at the end of each iteration of the loop. Okay, so score, we get tens, which is 9 for this call. This is true. No variables declared inside the code block, so we're not worrying about that. And then return A. So we cross this out, and we get the value A with quotes in result. Print result to the screen. I can cover up the heap here and get A without quotes. And then letter of 75. I can put this right here. Might be the best spot for it. Letter, score, 75. Tens is 7. We get in this code block, so we have a code block where we do have a variable declared. So we're creating a code block in this stack frame. Gets the value or variable result, which is going to be C. And then we're going to return C. So for this, we have to cross out the code block, cross out the stack frame. Oops, I forgot my return arrow. Mark is returning to this variable. So the code block is crossed out, the stack frame is crossed out, and we get the new value over here, C. Print C to the screen, no quotes over here. And then one more stack frame, letter, score, 30, tens, 3. Mark is returning to result. This returns F. Oops. And then print F to the screen. Hey, and we still got a few minutes left. Got through the trace tool. Actually, that went okay doing the trace tool. Maybe I can... Maybe for Thursday's lecture, I'll try to do them live in the tracing tool. Of course, these are pretty simple ones. Once they get more complex, it's tougher. Then I forget my talking points too sometimes. The slides keep me on track. Okay, any questions about any of this? We crushed it today. We got through all of the content. And by the way, once you know everything in the syllabus, please know everything in the syllabus first. But you can collapse this so it always goes to the slides, or use the jump to current week that Nicholas built for us. We got through all of our content here. Oh, I didn't go into IntelliJ. So IntelliJ is what we'll use, what I recommend you use, I should say, for writing your code. And this is with the examples. Actually, you know what? Yeah, I would install IntelliJ today. You should start that. So let me show a little bit of IntelliJ. Can I just close this? Usually this is in lab. I haven't done this in lecture in a while, so I got to remember to do it. When you go to the examples repo, one of the first things I'd recommend you do, go to the examples repo, go to code, and copy this URL. Go into IntelliJ. The interface is a little different in Windows than on my Mac, so I don't know how to get back to the main screen. But you'll go to Git, Clone, and paste that URL. I have to change the directory name because I've already cloned it in the directory. I'll get that's not an empty directory. Then click Clone. Wait for it to think for a while. And then once you clone that and give it a minute, you'll have your source directory with all of the content for all the weeks. In week 1, you're going to have our content, and you'll see something like this. Sometimes you might not see this actually, but I'm going to configure my JDK. It's going to give me, for your purposes, probably no options here. If it gives you no options, go to download JDK and use whatever the latest one is. Oracle OpenJDK 22 will be fine. Download. So I'm going to update mine to the latest. I was running 20 before this. Any of the newer versions will work for you, as long as you're not using the latest features. Forget what version exactly is running in. It's taking a while to download. Is running in Autolab, but it does print. As soon as you submit, one of the first lines of output will be the exact Java version. If that is important to you, you can have it. Is there any way we can practice like UB Infinite for traces? No, that doesn't. That is something we're working on. We'd like to have exists, but there's a lot of challenges in setting that up. I would go through the lecture examples though. Anytime I have the solution for a trace in my slides, try to trace through that without looking at the solution, and then compare it to the solution after. Would be my best recommended way to practice. And you do have access to the tracing tool. You can use that as much as you'd like in practice mode, like I just did, and practice your traces like that. So once you have your JDK set up, then you can run your program. It does take a second. Java's compiled. That's what's taken a bit of time here, is the compilation process. I don't have time to get into the details of that since we are ending right now. But run your program, and then you can see everything print to the screen. I would get set up to be able to do that right now. Probably right now. There's no reason to wait. You can't wait long and get behind. And then just one more thing before we say goodbye here is for the programming test, there's one repo to clone for the programming test. It's the same procedure. When you're ready to start task 1, grab the link for the code, clone it the way I just did, and then edit your code there. And then when you're ready to submit, let's see if it's even set up here. I shouldn't have started this one so late. They keep moving this, but either file, export, project to zip file, or in tools, there's a pack whole project. They keep moving the button, but there's going to be a way somehow to package your entire project as a zip file, and then that's what you submit to Autolab to get your feedback. All right, but I'm over time. I gotta call it. That's lecture 1. Welcome to the summer. Don't fall behind. Let's do this. We all got this. And I'm gonna take a break, and then in half an hour I'll be doing this same exact thing again. All right. Take care. I'll see you in 2 days.